Dear student friends, I welcome you all to this series of biostatistics. Today we will discuss about the significance, confidence limits, confidence interval, and level of significance. So let's start. This is one of the important topic or important concept in biostatistics. This is my YouTube channel, Professor Dr. Shafi. Please subscribe, like, and share, and please watch this complete video so that you understand this topic. So, what do you mean by significance, and when we use this terminology as significance? So, let us take the example of performing an experiment of effect of salt intake on blood pressure. So, when we perform an experiment or study, we get means and proportions from this study, from sample to sample and from sample to universe. So what do we mean by sample to sample? Means you draw many samples and record the blood pressure. You will get different mean values for blood pressure. And sample to universe. Sample means one sample you have drawn and you have calculated the mean of whole population or universe. So when we get these means and proportions, we find that each mean or proportion is different for one sample, from another sample, and also from the universe. So here we want to know that the significance of the difference observed in a result as compared with that of population or with that of another worker is different. Why it is different? It is different by chance, or it is different because of the salt intake. So please understand this, that there will be difference in the mean values of blood pressure due to chance, or there may be a difference by the effect of a particular factor like salt intake. So he finds that the blood pressure is different for different samples. So we need to conclude whether this difference is significant, means it is because of the salt effect or it is by chance. So when we say that the difference is significant, it means that there is a effect of the factor or the salt intake. So the difference observed is expressed in terms of significance or probability or relative frequency of its occurrence by chance. So usually when we say the result is significant, the p-value will be less than 0.05. Why this value of 0.05 is taken, that also we'll consider later on. But remember that whenever the p-value is less than 0.05, your results are significant, or you can say statistically significant. So there are two basic methods of drawing conclusions or knowing the significance of the results obtained. So we can find out the difference of significance by two methods. One is the estimation of a population parameter from a sample statistic. Population parameter, when we observe the mean of whole population, it is called as parameter. So any observation related to whole population is called as parameter. And if the observation is related to a sample, it is called as statistic. So whenever we say it is statistic, it is for the sample. Whenever we say it is parameter, it is for the whole population. So what we have to do, the estimation of a population parameter from a sample statistic. So you have taken the sample and you have observed, find out the mean, median, mode, and you need to estimate the population parameter from this sample parameter. How it is done, that we'll see later on. And then once you find out the sample population parameter and sample statistic, we need to develop a hypothesis like there is effect of salt on blood pressure or there is no effect of salt on blood pressure, and you need to test this hypothesis, or you need to test the population parameter which you have observed. So these are the two methods by which we can find out the significance in a given situation. So coming to the first, that is estimation of population parameter. We cannot draw large number of samples covering the entire population. So we cannot take whole population. We take a small population or small sample from the whole population and we perform the study. So in this case, we draw a sample and then we calculate the sample statistic in the form of sample mean. Then we set certain limits on both sides of the population mean. So just remember the normal distribution. If we take the population mean at the center of the normal distribution. On either side of the population mean, the sample mean will be distributed, and this is called as normal distribution. So we can set limits on either side of the mean population mean. So 1.96 on right plus 1.96 on right side, and plus minus 1.96 on the left side. So that will become the certain limit. So we know that for 1.96% on either side of the population mean, 95% observations will fall. This is the characteristics of the normal distribution curve. So these limits are called as confidence limits, and the range between these two is called as confidence interval. We will understand this on the sample on a photograph. So as for normal distribution, we say with confidence, we say with confidence that 95% of the sample mean will lie within the confidence limit. Now, what is the confidence limit? Population mean minus 1.96 standard error of mean to population mean plus 1.96 standard error of mean. So this is the confidence limit. In normal distribution, we have seen that the range of normality, that is mean plus mean minus 1.2 standard deviation and mean plus 2 standard deviation, or we can take as mean minus 1.96 standard deviation and mean plus 1.96 standard deviation. So 95% of the values will fall in this range. If we take 2 here, then it will be 90, more than 95, that is 95.5% of values will form. So to get exactly 95% of the observations, we take 1.96. So 95% confidence interval thus obtained will contain 95% of the sample. So any mean falling in this range is considered as the 95%. This is the 95% constant confidence interval, and the mean will fall in this range. 90% of the means will fall in this range. So that will be normal distribution. In case of population mean will also fall with these confidence limits or lie in the confidence. So sample mean will be distributed around the population mean. Here in this case, if we take the population mean, it will be distributed around the sample mean. So 95% of the population mean will fall in this range of mean minus 1.96 standard error of mean and mean plus 1.96 standard error of mean. So this is the range for the limit, confidence limit for the population mean. So population mean will fall in this range in 95% of cases. So the range obtained will contain 95% population mean. So in this 95% population mean, in this the 95% sample mean will fall in this range. So this range is called as confidence limit. So the probability or relative frequency of such occurrence will lie outside the range mean plus minus 1.96 standard error of mean by chance. So anyway, so this is the here we have the population mean, and the sample mean is distributed around the population mean up to this limit. This is called as confidence limit. So it is the 1.96 on either side of the population mean. So here it will be population mean minus 1.96 standard error, and here it will be population mean plus 1.96 standard error. So this is the confidence limit. So 95% of the population sample mean will fall in this because we have the population mean here. If any value is falling beyond this range is called as that this is in 95% level of significance, we call it as by chance. So 5% will fall in this range by chance, and 95% will fall normally in this range. So there is a chance of 1 in 20 times falling in this range of a mean by chance. So if confidence limits are extended to cover wider interval to 2.58, so 2.58 will cover the 95% confidence interval. So in this case, there will be a chance of 1 mean falling outside the confidence limit will be 1 in 100 times. So this is rarely used, 2.58%, whereas we use the 1.96 usually. So confidence limits or confidence intervals help us to estimate the location of a sample mean if the population mean is known or vice versa. So if population mean is known, we can find out the sample mean. If sample mean is known, we can find out the population mean. And also to locate the population mean where sample mean is known. So we can also find out the location of the sample mean or population mean with the help of estimating the parameter. So the limit of region at which we no longer regard the chance to be operating is called level of significance. So here the observation will not be by chance. It is by the effect of the factor. Take the example of the salt intake on blood pressure. So this limit is called as level of significance. So any value which is falling in the shaded area will be considered as significant, and the value falling in this unshaded or plain area will be considered as insignificant. So this is called as level of significance, and we take level of significance as 95%. So this is the application of the characteristics of the standard normal curve in case of the level of significance also. So this level of significance will separate this shaded area from the plain area. So if the chance limit is again extended, chance limit is set to 1.96 standard error, the 5% or 0.05 level of significance will be there. So if we take mean plus minus 1.96 standard error, there will be level of significance will be at the 5% or 0.05 level of significance, that is p value is equal to or less than 0.05. This is called as critical level of significance. So usually we take 1.96 and we take 95% confidence interval, and we take level of significance as 5%, and it is called as critical level of significance. So a value lying beyond this area is said to be significantly different from the population value. At this level, such extreme values will occur by chance only 5 times in 100 experiments. So usually we take 95% confidence interval, and if we take 2.58 mean plus minus standard 2.58 standard error, then the level of significance will be 1% and confidence will be 99%. And in this case, by chance only 1 in 100 results will fall beyond the confidence limit. So like this, we find out the level of significance. In most of the statistical studies, the level of significance are set at 5%. So level of significance is 5%, confidence interval is 95%, and they are the yardstick against which the probability P or relative frequency of outsample estimate is measured. So finally, we conclude in terms of significant or insignificant. So significant or insignificant indicates whether a value is likely to occur by chance or it is unlikely to occur by chance. So when we say that the value is occurring by chance, then the p-value will be more than 0.5. And we say that the occurrence is because of the effect of the factor, then the p-value will be less than 0.05. So here you can easily understand this is the range of normality. You can see here the sample mean is given and the population mean will fall in this range. 95% times it will fall in this range, and 5% on either side. So it will be divided into two parts, 2.5% and 2.5%. So the chance of falling in this range will be 2.5%, and in this area will be 2.5%. Total is 5%. So it is beyond confidence interval or confidence limit. So from 2.92 to 5.62 is the confidence interval or confidence limit. So in this range, if the value is falling, it is considered as normal. And if the value is falling in this range of 5%, it is considered as significant. So in most of the studies, we take 95% confidence interval and 5% level of significance. So please remember this and please try to understand. And significance is understood with the help of probability or p-value. If it is significant, p-value will be less than 0.05, and if it is insignificant, the p-value will be more than 0.05. So like this, we conclude. So thank you very much for watching this video. Please like, share, and subscribe my channel. Thank you very much.